This last section of chapter 3 is on percentiles and box and whisker plots. So in section 1, we talked about measures of central tendency, mean, median, and mode. Well, the median is actually going to be really important in this section. So we will revisit that. In section 3.2, we talked about measures of variation, range, variance, and standard deviation. Well, the range is also going to play a small part in this also. So we're going to be kind of combining concepts that both revolve around the center of your data and also the spread of your data. All right. So going back to the median, it's the middle of your data, whether it's the middle value, if we have an odd number of data points, or the average of the two middle ones for even number of points. But regardless, median is an average computed by using the relative position of the data. In section 3.1, I mentioned that the median is what's called a resistant measure. And it's a resistant measure simply because extreme values don't really affect it because it's based on location and not on the actual values of the data itself. So for example, let's say that you have an 81 median score on a biology test. Once you get all your scores in a numerical order, you'll find that 50% of the data falls either at or below that score of 81. So the median is an example of what's called a percentile. As a matter of fact, it's the 50th percentile. So before we go any further, let's talk about what a percentile is. For whole numbers p, where p is between 1 and 99, the pth percentile of a distribution is a value such that p% of the data falls at or below it, and 100 minus p% of the data falls at or above it. Now, I don't want us to get confused between a top something percent or a something percentile, right? Because when we think of percent, right? Let's say that you have a score that's in the top 5%. That doesn't mean that your score is in the 5th percentile. All right, that's not what that means. What the 5th percentile actually means is that 5% of the scores are either at your level or below that. As a matter of fact, if we look at, for example, the 95th percentile, let's say that your 81 is the 95th percentile of the scores on that examination. That means that 95% of all of the scores that were counted either fall at or below that score of 81, which means that 5% of the data is higher than your 81. So to say that something is in the top 5% is exactly the same as saying that it lies in the 95th percentile. Because 5% of your data is higher than that score. So here's another example. So here's a histogram that shows a 60th percentile. So 79.5 is the 60th percentile. That tells me that 60% of the biology test scores are either 79.5 or lower than that. And 40% is either at 79.5 or higher. Okay, so 60% of the data for a 60th percentile lies below the mark, and 40% of the data lies above the mark. All right, here's another example. Sorry. All right, here's an example. You took the English achievement test to obtain college credit in freshman English by examination. If your score is at the 89th percentile, what percentage of scores are at or below yours? So let's actually give this a number. Let's say that your score is a 90 out of 100. So a 90% score. If your score is at the 89th percentile, that means that 89% of the data lies in between a 0 to a 90. So 89% of the scores on any of the scores collected fall in that range. Whereas 11% of the scores fall between a 90 and 100. Okay, so again, when we think percentile, that's the percentage of data below the value that it's referring to. Here's another question. If the scores range from 1 to 100 and your raw score is 95, does this necessarily mean that your score is at the 95th percentile? That's not necessarily true. Let's say I have 10 scores, right? And let's say that the scores are 1, 3, 27, 95, 96, 97, 98, 99, 100. So here's an example. Here's 95. Does this look like 95% of the data? It doesn't. It actually doesn't. Okay? So the 95th percentile doesn't necessarily mean that, 95, a score of 95 is the 95th percentile. Because percentiles rely on two things. First, it relies on the values of the data themselves. It also relies on the number of values that you have. Okay, so just because you have a score of 95 doesn't mean that your score is at the 95th percentile. Okay, so usually in ideal situations you have 99 percentiles, and it divides the data set into 100 equal parts. So again, there's 1%, 1%, 1%, 1%. So you would say that the 4th percentile is everything that's 4% below, 96% above, those types of things. Now, percentiles are used in a number of different ways. The most popular percentiles, from my own experience, that have been used are for standardized testing and for baby sizes. I'll give you an example. When Charlie was born, that first year of his life, his rate of growth was very exceptional, to such a degree that for a while his size was in the 95th percentile, which means that 95% of the kids' sizes recorded were either at his size or smaller. So the easiest way to find percentile, if you have a set of data, is to order them from smallest to largest, like you would if you're finding median or anything of that nature, and then find a value such that that percent of the data falls at or above it. So once you have your data in order, then you find the value such that a certain percentage of the data falls below that value, which we'll see with what's called quartiles. Quartiles are a very popular application of percentiles. As a matter of fact, they're used so frequently that there's a special procedure for calculating them. A quartile is a percentage that divides the data into fourths. I mean, think of the word quartile, right? Has the same root as quarter, right? A quarter divides $1 into fours. Football games have 4 quarters, right? Basketball games have 4 periods, all that stuff, right? So a quartile, there are 3 quartiles, and those 3 quartiles divide your data into 4 parts. You have your 25th percentile at your first quartile. So that's the first 25% of your data. Then you have the next 25% from Q1 to Q2, the second quartile. Then the third quartile from Q2 to Q3, that's another 25%. And then from the third quartile to your maximum value, that's the other 25%. Now, the first quartile, I mentioned earlier, that's your 25th percentile. The second quartile is the median. It's the 50th percentile. So again, that's why we need to revisit the median. The 75th percentile is your third quartile. Okay. Now, how do we calculate it? Well, first, like I mentioned earlier, you definitely want to order your data from smallest to largest. Then you want to find the median. And it's the second quartile. Now, why not find the first quartile first? Well, think of it this way. If you have a number line and you're trying to cut it into 4 equal parts, you don't want to just like by hand divide it into 4 equal parts right away. The easiest way to do that is to cut it in half so that you have 2 equal parts, and then take each part and cut that in half. Then you have 4 equal parts. So that's basically the logic here in finding the median and the first and then the quartiles. So the first quartile is the median of the lower half of your data. Okay. The third quartile is the median of the upper half of your data. Now I want to highlight these key words. Not including the median, the second quartile. When we look for the first and the third quartile, we are not including the median. It doesn't matter if it's the middle value or the average of the 2 middle values. We do not include the median when we're finding the first and the third quartile. Okay, so here's an example. Here's the data. I'm looking for the median, the first and the third quartile. I also want to look for the minimum and maximum too, because that's going to play a role later on in this section. So obviously my smallest value is 1. My largest value is 14. All right. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's a set with 11 values. That's an odd number. So because it has an odd number, it's going to be really easy to find the median. All right. So when we look for the median, we're just going to go work our way down. And here we go. There's our second quartile. That's our median.
How long before you finish? Because they're coming in the spray.
Okay. Shouldn't be much longer.
Right down the hall.
All right. So we got your minimum, your median, and your maximum. Okay. So our first quartile is this half of the data. Is going to be in this half of the data. The third quartile is going to be in this half of the data. All right. So if we just work our way down here, there's our first quartile. Here, work our way down. Here's our second quartile. Or I'm sorry, third quartile, I should say. Okay. Then we have what's called the interquartile range. So it's useful when you're using relative position as a measure of data spread. The interquartile range is basically the difference between the third and first quartiles. It's a range, so you're subtracting one value from the other. Okay, so you're taking your third quartile minus your first quartile. But what it does tell us, it tells us the spread of the middle half of your data. So it is so in a way, it's kind of a combination of measure of central tendency and measure of variation. The interquartile range tells us just the spread of, it tells us a spread, but it also tells us the spread of the middle half of our data. If we go back to the previous example, here was our first quartile. Here is our third quartile. If I subtract those, I get 7 as my interquartile range. Now, 7 is a pretty small number, but so that tells me that the middle half of your data isn't necessarily too far spread out. I mean, look at the data itself. I got 7, 9, 10, 12, even a 5. These are relatively close values. So again, just like variation or just like standard deviation, the smaller your interquartile range is, the less spread out your middle half of the data is. Same thing, and similarly for a larger interquartile range, it's a larger spread. So here's an example. Consumer Reports did a study of ice cream bars. 27 bars with taste ratings of at least fair were listed, and cost per bar was included in the report. Just how much does an ice cream bar cost? Here's the data expressed in dollars. Obviously, the first thing we want to do is put this data in order, and here it is. So here's the data. It's in numerical order. So here's my minimum value. Here's my maximum value. I want to go ahead and find the median. Looking at this, there's about 27 values up here. So again, median is going to be pretty simple. I'm going to be able to look for the middle part of my data. So I'm going to scroll until I find the middle. Oh, wait, hold on. I messed up. Again, you should always double check, kind of a measure twice, cut once kind of thing. Here we go. Here's my median, 50 cents. All right. So first quartile. Here we go. First quartile, 33 cents. Now for my third quartile. Again, we don't include the median. Here's my third quartile, $1. Finding my interquartile range, that's $1 minus 33 cents. That's 67 cents. All right, so again, small interquartile range. Small interquartile range, that tells me that this data is not very spread out in the middle. In fact, here, looking at here, the only big jump that I can see is from 63 cents to 84 cents. Right, so that's not very spread out that much. Now, with quartiles, the quartiles together with your low and high data values give us what's called a 5-number summary. Now, the 5-number summary is given as your lowest value, your first quartile, your median, your third quartile, and your highest value. So in this example that we just did, go back here, 16,123. Sorry. So 16 cents, 33 cents, 50 cents, $1, 123. So again, 16 cents and 123 cents were my smallest and largest values. 33 cents was my first quartile, 50 cents was my median, and $1 was my third quartile. That's a 5-number summary. Now how else can we use this visually to express the data? Well, we use what's called a box and whisker plot. So a box and whisker plot is basically just a graphic display of the spread of data about the median. It's pretty much just a visual representation of your 5-number summary. The box of the box and whisker plot shows the middle half of your data, your interquartile range. And then you have one whisker on the bottom 25% of your data, and another whisker on the top 25% of your data. So when we're making a box and whisker plot, first thing we want to do is we want to draw a scale that includes your lowest and highest data values. Then, of course, once your data values are set up, you want to draw a box from your first quartile to your third quartile. Then you want to include a solid line through the box at the median level, or where your median is, and then draw the whiskers, again, from your lowest value to Q1 and Q3 to your highest value. Now, the reason that the graph looks like this when I pulled it from the textbook is basically because your textbook likes to do vertical box and whisker plots. I do not. I would much rather horizontal box and whisker plots, because it looks neater. It looks a lot neater. But then again, you see the box around your interquartile range, the line down the median, and your whiskers on the first fourth and the last fourth of your data. So let's use this as an example. Make a box and whisker plot showing the calories in vanilla flavored ice cream bars. Use the plot to make observations about the distribution of calories. So here's the data. It's already ordered from smallest to greatest, so we don't have to do it ourselves. And it's already identified where the median is. There's a even number of values, so we're going to add these two values up and divide, and we're going to add those up and divide by 2. So let's do that right now. So I have 234 plus 209. I get 443 divided by 2. I get 221.5. That's my median. So here it is, my median here. And again, because 209 and 234 aren't my median, I can include it when I'm looking for my quartiles. But before I do that, let's recognize our minimum value and our max value. 111 and 439. All right, let's go ahead and look for our first quartile. So we're going to start here, work our way down. Here we go, 182. Then we'll look for our third quartile. So I'm going to start here. And there we go, 319. All right, so there is my 5-number summary right here. All right, this is my 5-number summary. So now we're going to draw our box and whisker plot. Now remember, going back to chapter 2, whenever we draw a graph, we have to label it, and we have to, we have to give it a title, and we have to label our axes with the appropriate units of measurement. So this problem was on calories in vanilla ice cream bars. So, and because it's a graph of distribution, we're gonna label it as such. So we'll call this distribution of calories in vanilla ice cream bars. Okay, I'm going to draw my scale, and I'm going to draw my scale so that it includes the minimum and maximum. Now, what I'm going to do is I'm going to start at 0, and I'm going to mark intervals of 25. So use your best judgment to figure out what scale you want to put on your graph. So 25, 50, 75, 100. 25, 50, 75, 200. 25, 50, 75, 300. 25, 50, 75, 400. 25, 50, 75, 500. Now it's not perfect, but that's the best I can do for right now. All right, now going back to the steps on how to make the box and whisker plot. The fourth step, so the fourth step here, where you're drawing the whiskers, I'm actually going to do that first. Now, you don't have to do these steps in exact order. Now, this you do have to do first. But as far as these go, you don't have to do these in a specific order. Sometimes I'll do the fourth step first before the second and third step because I like to put the points on my 5-number summary down first before I draw my box and my whiskers. So that's what I'm going to do first. I'm going to place my points on this scale. So 111, that's between 100 and 125. 182, that's between 175 and 200. My median was 221.5. That's right before 225. 319 is right before 325, so I'm going to put that here. And 439 is right after 425, so I'm going to put that about right here. Now I'll just go ahead and erase this part here. All right, so now I want to draw my whiskers first. Again, you don't have to do this first. You can do the box first, but I like to draw the whiskers first. Go ahead and erase this here. Now I'm going to go ahead and draw my box. And then I'll draw my line right down the median. And there it is. What does it say about the distribution of these calories? Which, by the way, again, we want to make sure that our axis is labeled. And you only need to do one axis because you're drawing a box. You don't need an X and Y axis for a box. So this tells us that the amount of calories in ice cream bars towards the center is more consistent. It's not as spread out on this side of the graph as it is on this side of the graph. They're way more spread out in the top 50%, the top half of the graph, right? But what does this actually tell us? Well, obviously, it tells us the 5-number summary. And of course, it tells us how much the data is spread around the median. That's by definition. And of course, it tells us where the middle half of your data is. But one thing that it also does is it tells us if there are any outliers. And here's how to do it. There's actually a formula that can help us find outliers. So if X is a part of a data set, then it's an outlier if it falls less than this or greater than this, right? So either less than your first quartile minus 1.5 times IQR, or greater than Q3 plus 1.5 times IQR. All right. Actually, let's apply that in this example here. Here's my 5-numbered summary. Here's my first quartile. Here's my third quartile. My interquartile range, 319 minus 182, that's 137. So 1.5 times this. $205.5. 205.5. All right. So any outliers that occur are either going to be less than this minus this, or greater than this plus this. So let's find out. So let's take 182 minus 205.5, and that's negative 23.5. So obviously there's no negative values in our data, so that tells me that there are no outliers in the 50th percentile of your data. Let's try the other side. 319 plus 205.5. That's 54. Oh, sorry, not 54. 524.5. This is my highest value, nowhere near this. So that actually tells me that I don't have any outliers on the top half of my data. So based off of that information, we can conclude that our data set does not have any outliers.